Okay, hi. In this example, we're going to learn how to solve a system of equations by using substitution. So remember, substitution is solving for one variable, either x or y, or this 2x or this y, and solving for one of those, and then replacing it into the other equation because we can't solve an equation with two unknowns. And right now, each of our equations have an x and a y, and so we can't solve them. So let's go ahead and get right down to it. So if we're going to solve this system, we have to be smart and choose the best variable to solve for, which is going to be this x here. If we solve for this x, the reason being is that when we move this y to the other side, it's one move or one step to set this one up ready for substitution, and we're going to have a positive y value. So this x is probably the smartest value to solve for. So let's go ahead and do that. We're going to get x equals y plus 11. So we've already set it up and solved for it. Now that we've got that variable solved for x, we're going to go ahead and plug that back into our other equation. So remember now, what we found out is that y plus 11 is equivalent to x. And so wherever we see x in the other equation, we can replace it with y plus 11, and it's true. And by doing that, let's write it as we do it, by doing this, replacing that x value with y plus 11, now we only have one variable that we have in our equation, and we can now solve for it. So let's go ahead and finish this up. If we first thing we should do is distribute our 2, so we're going to get 2y plus 22 plus this y carrying down equals 19. In this part, we should probably combine like terms, so we're going to get 3y plus 22 equals 19. Of course, we're going to use reverse order of operation, which means addition and subtraction should be first, so we're going to subtract off this 22 from both sides. It turns to 0, so it doesn't exist on the left. We get 3y equals 19 minus 22, which is going to give us negative 3. And of course, we're going to finish this off by dividing by 3 on both sides, that turning to 1, leaving just a y equal to negative 1. What we found thus far, is the coordinate for the point, because that's what a solution is to a system, is a coordinate point. We found the y coordinate. So we can place that there. We still need the x-coordinate. So if we need the x-coordinate, we have to take this back up and plug into either equation. It doesn't matter. Whatever the easier one is the one that I would choose. Looking at the top equation, it looks easier to deal with than the bottom one. So let's use that. Wherever we see y in this top equation, wherever we see y, we're going to replace it with what y is equivalent to, being negative 1. So I'm going to write x minus, because that's the negative here, in parentheses, use parentheses to show that you substituted something in, so negative 1 equals 11. It's important that you get this part right, because you may come up with a negative value here, but as you can see, it's a negative times a negative, which is going to result in a positive 1. That would be something to note there. So to solve for this, it's pretty simple. We're going to subtract 1 to the other side, and we're going to find out that x is equal to 10. So our coordinate point, or the solution to this system, is the coordinate point 10, negative 1. All right, let's look at another example here, and you can see that this one's starting to get more complex. If we're smart, this is still a single step to get ready for solving or using substitution, because we can use that y there. However, if we used any of these other variables to solve for, right, to isolate by itself, we would have two steps. We'd have to move a term away from it and then divide. That would be a multi-step. You're only forced to do that when every one of your variables has a coefficient. When it doesn't, that's the smartest one to choose because it eliminates one extra step. So is it terribly different or wrong if you go with another one? Absolutely not. But it's much smarter to go with this y. So we're going to solve for that y by moving this 6x to the other side. So I'm going to go ahead and add 6 to both sides. Again, dropping 0 off here. So what I end up with is y is equal, oops, forgot to write the x there, y is equal to 6x minus 7. All right, now we have a value that y is equivalent to, which we're going to take, and wherever we see y in the other equation, we're going to replace it so that we get down to just one variable. So let's write that out. We end up with 3x plus 2 times, instead of y now, we're writing what it's equivalent to, which is 6x minus 7 equal to, oops, top equation, equal to 4. All right, now we go ahead and use our solving techniques at this point. First thing we should do is take care of that distributive property. 3x is going to drop down. I get 2 times 6, which is going to give me 12x, and I get 2 times negative 7, which is going to give me negative 14, is equal to 4. All right, next I'm going to combine like terms, so I'm going to get 3x and 12x to make 15x minus the 14 equals 4. Now I can start my solving process finally. I'm going to use reverse order of operations, which means addition and subtraction. If I'm solving for this x here, I'm going to remove any addition and subtraction first. So I'm going to add 14 to both sides. I get 15x is equal to 18. Again, those drop out and turn to 0. Finally, I'm going to go ahead and divide by 15 to both sides. Is it okay that I didn't receive a nice pretty integer? Absolutely. Okay, so 18/15 is, remember, our solution to a system should be a coordinate point. So we now have the x coordinate. So we have 18/15. It's not going to be pretty to play with, but that is what we have to plug in. So this here is now the equivalent of x. We can take that into either equation to replace x so that we only have one variable to solve for. Which one we pick? So let's take the top one. So now wherever I see x in the top equation, instead I'm going to write 18/15. So I'm going to take 3 times 18/15, because that's what x is equivalent to, plus 2y equals 4. All right, looking at this scenario here, I have to multiply this out, and we're dealing with a fraction. But I can see here that this 3 and that 15 are going to divide nicely, leaving this to be 18/5 plus 2y equals 4. I'm going to go ahead and use reverse order of operations here, because I'm solving for this y value, which means that I need to remove any addition and subtractions first before this multiplication of 2. So I'm going to go ahead and subtract 18/5 from both sides. That turns to 0 here, so I'm left with a 2y equals 4 minus 18/5. Now we need to deal with this fraction, but you can see here that this is a 4 over 1, so I'm going to multiply this by 15 over 15, or I'm going to multiply it by 5 over 5, because this should be 18/5. So I'm going to multiply this by 5 over 5. So I'm going to have 2y equals 20/5 minus 18. Now I have common denominator, so I can combine those two. So I'm going to get 2y is equal to 2/5. And now I need to remove this 2. So I'm going to divide by 2, which over here will look like a multiplication of a half. And so I'm going to have y equals 2/10. And so if I put that in there, 2/10, the solution to my system should be 18/15 and 2/10. Again, if you wanted to check this to see if your algebraic work is correct, you'd probably want to graph it. Might be the easiest way to estimate your solution to see if it's correct. Or, additionally, you may plug these back into both equations, both values, the x and y coordinate, and see if it makes a true statement. All right, there you go. You've seen how to solve substitution with a little bit of fractional work in it. All right, we'll see you in class.